Welcome to the new section of this course, Visualizing Streaming Data. Now, let's move on to the video, Simple Streaming Line. Let's start with Simple Streaming Line. For our first example, we're going to create two simple streaming lines. So here they are, as seen on the screen. We have got horizontal lines, which move from the right of the screen to the left. This graph is a simple axis which shows the current time and which moves together with the line graph. Whenever you move your mouse, the distance traveled is stored and rendered as two lines. Each point in the graph represents the total distance traveled along the x-axis or the y-axis. To accomplish the graph, we need to take these steps. The first thing we need to do is define the various scales which we can use for rendering the scale at the bottom, and which we use to determine the x and y positions of each graph element. When we've got the scales, we can start collecting the mouse information which we'll use to draw the line graph. Once we've got the mouse data, we'll set up the animations for the line graph and the bottom axis. Finally, we'll clean up the visualization a bit by adding the text in the upper left corner and use a clip path to hide the new points entering at the right side of the graph. Now, let's look at the setting up the scales. To render the graph, we'll be using a couple of scales. In the beginning of this code fragment, we first define some properties which we use throughout this visualization. The duration property determines the period we collect mouse data for. With endpoints, we define how many points make up the graphs we draw. In this case, we use 120 points with a duration of 500 milliseconds. So the complete line graph represents a time period of 1 minute. Finally, we create an array which we fill with empty data that we'll use to draw the line. Next, we set up the scales. We use 3 scales as defined here. First is the x. We use it to determine the x position of the points in the line graph. This is a simple linear graph which divides the width based on the total number of points. Note that we don't use a domain from 0 to n points, but to n points minus 2. The reason we do this is that we don't want to render the newest 2 points. More on that later in this section. Next is the y. This linear scale is used to determine the y position of each point of the graph. This is a simple scale where we just set the max to an arbitrary value, 500 in this case. And the last one is x time. We use a scale which we haven't seen before, the d3.scaleTime. This scale works in the same way as a normal linear scale, but uses dates to define its domain. In this case, we create a domain which mirrors the domain for the x-axis. We first define now with an offset of 1 duration. Next, we define a time scale that represents the total duration of our graph. After that, we will be collecting mouse data. With the scales defined, we need some data to show. For this example, we'll use the mouse as our input. When you move the mouse move events are generated. We'll use information from this event, specifically the screen X and screen Y values, to determine the mouse distance traveled. To collect this, we add a mouse move listener on the body element using the d3.select on function. The total distance traveled is stored in the total X and the total Y values, which we use later on when rendering the individual data points. Next, we will be setting up the animations and the graphs. To draw a line, you pass in a function which is used to determine the x-coordinate based on the data, and a function used to determine the y-coordinate. D3 also allows you to pass in what the line should look like. Should it be curved, closed, straight, or one of the other options? If you comment these lines and check the output, you will get a linear curve, which is just a polyline through all the points. If we don't want direct lines between the points, we use the d3.curve step function as shown here. For our example, though, we'll use a d3.curve basis, which draws a nice fluent line through all the various data points, as we've seen in the beginning of this section. One remark here. When we saw the scales in the beginning of this section, we mentioned that we defined the domain of the scales so that they ignored the last 2 data points. The reason is that if we draw a curve, the y position of the last 2 points jumps around because D3 wants to draw the curve nicely through these points. By defining the scale like this, the last 2 points of the line are drawn outside the specified width. We still see them at this point, but by adding a clip path, we can hide these 2 fluctuating points, and the result is a nice streaming graph. So we start by creating a group that contains the lines using this highlighted part. We don't do anything with the bound data yet. We just assign the array to the 2 different paths and add some classes for CSS so that we can easily select them later on. Note that we use datum instead of data to assign the array. With datum, we don't use the enter, exit functions, but directly bind the data to the path element we just added. Just what we did for the lines, we do for the access at the bottom. We define a d3.axisBottom function by passing in the d3.scaleTime we created earlier. We automatically get the correct ticks and labels in the access. We attach the access to a newly created G group and position it at the bottom of the graph. At this point, we've created the groups that'll hold our lines, and we've drawn the bottom access. We haven't, however, drawn the lines yet. To create a nicely flowing line from right to left, we're going to take this approach. Push a new data point onto the array. Draw the lines with this new point, which is drawn off-screen. Start a transition to move the groups to the left. Also, start a transition to move the access at the same time. Once the transition is done, remove the first element from the array and restart the process. The steps we just saw now will look like this. We kick off the steps by first calling group.transition. This will start a transition. When the transition is started, we use the on event to trigger a call to the render function. In the render function, we execute the steps as seen previously. We add a new element to the data array, clean up any transform parameter previously set, and draw the lines using the my and line mx path generators. Next, we redefine the domain for our timescale. After drawing the lines, we start a transition to move the lines 1 step to the left. If the current transition is still running, the new one will be queued. Once this new one is being executed, it will queue another one, and the process is repeated. At this point, we've got a fluently running graph that can be configured through the duration and endpoints properties we saw at the beginning. For example, if we have a duration of 5,000 and endpoints is 200, we get a line like this. Finally, we will see the clip path and extra information. In the beginning of this section, we created the X scale like this. Basically, this means that the data points data endpoints and data endpoints minus 1 are rendered outside the provided width. Since we always set up our chart to have margins, these 2 points will be drawn there and still be visible. To hide these, we'll use a clip path again so we can exactly determine what the visible area of the chart is. The clip path itself is defined as a simple rect element like this. The only thing left to do is assign this clip path to our main SVG element as shown here. Now, when we run the example, the graph smoothly transitions into view. The final items we add to our graph are 2 simple counters at the upper left corner. These are just simple text elements as highlighted. The value of these elements is set whenever we receive an event in the onMouseMove listener. In the render function, we reset the value of those elements back to 0. So, in this video, we defined the update interval as a duration in our JavaScript. If you've got a high-frequency data source which pushes information at regular short intervals, we could also redraw the chart on each push. This is an approach we'll use for the upcoming example. So here we've come to the end of this video.